China makes more stuff than anyone else on Earth. Phones, cars, buildings, clothes, solar panels. You name it, China builds it. But here's the part nobody talks about. Every single one of those things eventually breaks, wears out, or dies. And for decades, experts in the West said what comes next was basically impossible, too messy, too mixed, too expensive to ever be worth the trouble. Sorting a dead battery from a broken solar panel from a demolished building was supposed to be a losing business, not a real industry. China looked at that same mountain of junk and saw something else entirely. Not a mess to bury, but a resource to mine. Using machines and systems most people have never even heard of, China quietly built the exact system America swore could not work. And it starts with the strangest mine you will ever see, hidden inside a dead car battery. Think of an electric car battery as a locked box full of treasure. When the car stops working, most people just see a heavy black brick. But inside that brick sit metals that companies around the world pay billions to dig out of the ground. Lithium, nickel, cobalt, manganese, copper, and aluminum. Someone already did the hard work of digging up and cleaning these metals. They already packed them into a neat box. The box is shut tight, but the treasure is right there waiting. China starts by being safe about it. Every dead battery gets logged and checked. Any power left inside has to be drained first, because a charged battery that gets crushed can catch fire or even explode. Once it is safe, workers check if it still has life left. A battery too weak for driving might still work fine storing solar power in a shed for a few years. That buys time, but it does not solve anything. Every battery dies eventually. For the ones that are truly done, workers take the pack apart and feed the pieces into massive shredders that rip through metal casing, plastic, and wiring. What comes out is a fine dark powder called black mass, the concentrated heart of the battery. Chemical processing pulls the metals back out and sends them straight to factories building new batteries. A battery made from a battery. The circle closes. The scale is staggering. China handles roughly 70 to 80% of global battery recycling and closer to 90% at the final refining stage. In July 2025, a new national standard reclassified qualifying black mass as a sellable product instead of hazardous waste. Right as Europe tightened its rules and called the same material dangerous, China opened the door wider. But the story is not as clean as it sounds. Licensed recyclers, with all their safety gear and permits, are running at only 20 to 30% capacity. Not because batteries are scarce, but because small unlicensed shops pay more for them, since they spend nothing on safety. The system is real, and it is enormous. It is also running half empty. Nobody likes to talk about what happens when a solar panel gets old. It feels wrong because panels stand for clean energy. But a panel that spent 30 years bolted to a roof is not a clean energy hero anymore. It is 20 kilograms of glass, plastic, and metal fused into one sheet that refuses to come apart. By weight, the panel is almost boring. About 2/3 of it is glass. Roughly a sixth is aluminum. But weight is the wrong way to measure it. Look at it by value instead, and everything flips. More than 60% of the money sits in a paper-thin layer of silver buried inside the silicon cells. So thin, you cannot even see it without tearing the whole panel apart. It is like a painting where the frame is heavy and the canvas is tiny, yet the canvas is worth a fortune. On paper, recycling should be simple. Pull off the aluminum frame, remove the cables and junction box, collect the glass, then separate the silicon copper, and silver underneath. In reality, you are fighting 30 years of deliberate engineering. Every layer in that panel was sealed to keep out rain, hail, frost, and sun for decades. The same toughness that let it survive storms now makes it almost impossible to take apart. Getting to the silver means heating the panel to extreme temperatures or dissolving the glue with chemicals, and both options cost serious money and energy. The wave coming is not a guess, it is a schedule. China's solar industry projects around 18 gigawatts worth of retired panels by 2030, roughly 1.5 million tons of material. By 2040, that number balloons to over 250 gigawatts, close to 20 million tons. The reason is simple. China installed an enormous number of panels in a very short window, which means they are all going to age out at roughly the same time, like an entire neighborhood built in 1 year, all needing new roofs at once. Solar panels are a problem of things fused together that refuse to separate. But the next waste stream flips that completely. It arrives in millions of loose, scattered pieces, and by sheer size, nothing else on this list comes close. Forget batteries and solar panels for a second. By pure weight, construction and demolition waste is the biggest pile in China. Nothing else even comes close. When a building comes down, it leaves behind a messy mix of concrete chunks, steel bars, bricks, asphalt, glass, wood, drywall, insulation, and a pile of mystery debris nobody can quite name. Compared to battery chemistry or solar panel glue, the process here is almost simple. Trucks haul rubble in from demolition sites. Workers pull out anything big enough to reuse. Magnets grab the steel. Everything else, the concrete, brick, and stone, gets fed into crushers that smash it down into smaller chunks. Screens sort the pieces by size, and air jets blow away the light junk like wood splinters and scraps of plastic. What is left is called recycled aggregate, a fancy name for gravel, and it goes into road bases, fill dirt, and sometimes concrete blocks. The process being simple is exactly what makes the numbers so painful. In 2020, China generated about 2.6 billion tons of construction and demolition waste. Of that entire mountain, only around 312 million tons got recycled. That is just 12%, with the overall recovery rate sitting below 40% by most estimates. Many cities are still quietly dumping rubble into landfills. For comparison, the United States produces far less construction waste overall, yet recovers close to 75% of it. Chongqing makes the scale painfully clear. In 2021, that one city alone produced 167 million tons of construction waste, more than half of its total solid waste output, with a recovery rate under 30%. So why does something this simple perform so badly? Money. Crushed gravel sells for almost nothing. Dumping rubble in a landfill costs even less, especially with fees kept low for years. If dumping costs $5 and crushing costs $10, nobody volunteers to crush it. Quality is the other wall. Rubble from a messy demolition is full of surprises, drywall, plastic pipe, stray wiring, and engineers will not approve it for anything load-bearing. Most of it ends up under roads, where the only requirement is that it stays put. Construction waste is a story about volume. The next stream hides its value in pieces smaller than a grain of rice. Here's a fact that sounds fake, but is completely real. A ton of rock pulled from a gold mine might yield just a few grams of gold. A ton of old circuit boards can give you far more. The richest gold deposit near any Chinese city is not buried underground. It is sitting in desk drawers, warehouse shelves, and boxes full of dead phones. People call this urban mining, and it is not just a catchy phrase. It is a real statement about how much metal is packed into our old gadgets. Electronic waste covers a huge range of stuff: phones, laptops, circuit boards, televisions, fridges, washing machines, motors, cables, screens, servers, and telecom gear. Inside all of it sits copper, aluminum, steel, gold, silver, palladium, plastic, glass, and sometimes rare metals most people have never even heard of. The recovery process runs like a careful assembly line. Workers collect and sort first, pulling batteries and hazardous parts out immediately. Reusable components get set aside. Then dismantling begins, sometimes by hand, sometimes by machine. Magnets grab the iron and steel. Eddy current separators use invisible magnetic fields to flick out aluminum and other metals. Optical scanners sort what remains, and finally smelting or chemical processing pulls the pure metals free. Smelting means heating everything in a giant furnace until the metal melts and the junk floats away. Chemical processing means dissolving the metals out of crushed boards entirely. China has been pushing hard to formalize this. Between 2024 and 2025, about 53 million used appliances and phones entered standardized dismantling channels, a number growing 12% a year. One licensed plant in Fujian alone handles more than 2,000 dead appliances every single day. A fridge goes in one side and comes out as separate streams of plastic, metal, and foam. A washing machine follows a completely different path. Its concrete counterweights, motor, drum, and control panel all peeled apart in sequence. The money here actually makes sense. Gold and silver are valuable enough to justify the fancy factories. If one circuit board holds more gold per ton than a ton of mined ore, the equipment pays for itself. The next material is not so fortunate. Its valuable parts are cheap, dyed, stitched from 5 different fabrics, and nearly impossible to pull apart. Grab a shirt from your closet and check the tag. If it says 100% cotton, that is an easy problem. But if it reads 60% cotton, 35% polyester, 5% elastane, plus a printed logo, a water-resistant coating, a metal zipper, and plastic buttons, you are holding something almost no technology on Earth can turn back into a new shirt. Purity is the whole game, and modern clothing is built on purpose to be impure. China's answer is chemical recycling, breaking polyester down to its basic building blocks and rebuilding it from scratch. One company in Jiaxing already produces recycled polyester at 99.9% purity, with 50,000 tons of yearly capacity now and a target of 500,000 tons by 2030. The catch is that it only works on pure polyester. Mixed fabrics still stump the process completely. In 2020, China generated 22 million tons of textile waste and recycled only about 20% of it. Even the government's own 2030 target tops out at 30%, which quietly admits that 7 out of every 10 garments will never come back. Food waste tells a different story. In Shanghai alone, wet waste made up about 60% of household garbage, and it ruins everything dry it touches. On July 1st, 2019, the city made sorting mandatory across 24 million people, with real fines for getting it wrong. The backlash was loud at first, then it worked. Sorted food waste more than doubled, arriving at processing plants at 99.5% purity, clean enough to feed into sealed tanks where bacteria break it down into biogas for electricity. That cleaner, drier leftover trash feeds directly into China's incineration network, now 1,129 plants strong, generating enough power to cover up to 7% of the country's residential electricity. Over 78% of city trash gets burned today, while landfills keep shrinking into the background. Sorting feeds burning. Burning finishes what nothing else can recycle. Batteries, panels, buildings, electronics, fabric, and food scraps all funnel into one connected industrial machine, running today at a scale nobody outside China saw coming. China did not just recycle materials, it built an entire industrial ecosystem where dead batteries, broken panels, demolished buildings, old electronics, worn clothes, and food scraps all feed one connected system. This is the exact scale and coordination Western analysts long insisted was economically impossible, running today, generating real revenue and real power for hundreds of millions of people. The silence coming from the rest of the world is not disinterest, it is catching up. If you found this as eye-opening as I did, hit like and subscribe. And tell me, which of these waste streams would be hardest to fix where you live?